Number 12, we're going to create a function called off diagram. We're going to take any input n by n matrix A, and we're going to create a column vector V, which is n by 1. Each element of V is going to be the sum of all the elements in A, of row I of A, except the diagonal element. And then we're going to use a for loop with two inner for loops without an if statement. And we cannot use any inbuilt functions except for getting the dimensions. So let's create an example. So if A is a 5 by 5 matrix, so we have 5 elements in each row, we're going to take the sum of every single element except the diagonal elements. So anything on the diagonal, which I'm going to circle, will not be added. And then when we take the sum of each, we're going to get a column vector that has 5 elements, and that's equal to V, right? So this will be arrow because that's our output. So how we're going to do this is we're going to have a big for loop, and then within that we're going to have two for loops that will work with the rows possibly, and that will help us get our running sum. So let's just start off by writing our function name, and we'll get into how exactly we're going to do this. So we're going to say function V equals off diagram, input A. So in order to do this, we have to get the dimensions of A. So we say RC equals size of A. Then a nice thing to do is pre-allocate V. So instead of concatenating it and extending V and making the loop take longer, we can just pre-allocate it. So one way to pre-allocate that is just say V equals zeros. So that will make a zeros vector. And we're going to have R, which is the amount of rows that we need, and then 1, which is just one column. And then we can start doing our for loop. So we're going to say for, and then we're going to start off with our rows. We want to go through we want to do our rows first, and then we want to go through our columns on both for loops in order to get the running sum. So we're going to say for I equals 1 through R. So I'll make us go through all the rows. Then we're going to have our running sum on every single row. We want a sum of every single row. So when we go through every row, we want to start off our new running sum. So I'm going to say run S equals 0. Then we're going to start our new for loop. So for J equals, so this is going to represent our columns. Now, suppose you're on row 3. So suppose you are on row 3. So your diagonal is on column 3, right? So this is row 3, and this is column 3, right? That's where your diagonal's at. The amount of rows you have is the total amount. So we know that in this scenario, in this little example here, we know that R equals 5 and columns equals 5. If our diagonal is on row 3, column 3, we want to go to column 2. So we want to go here. We want to go to column 2. So we want to go 1 through 2, and then we're going to end that first for loop, and then we're going to go through 4 through 5. So how we're going to write that is we're going to say 1 through I minus 1. So why is that? So suppose we're on row 3, like I said, that means I equals 3. So in this case scenario, I equals 3. So if we go to I minus 1, which is I equals 2, oh, look at that. That goes to column 2 like we need. So we're going to say that works. So let's say another example. If we're on row 5, so if row 5, then I equals 5, then our diagonal is also on column 5, so we want to go to column 4. So I minus 1 will equal 4, and that will help us get there. So this works. So then we can say our run S, which is our running sum, equals run S plus, and we're going to index. So we're going to say A, which is our matrix, and the row we're on is I, and the column we're on is J. And we're going to end that for loop. Then we're going to start our next for loop. So we're going to have 4, and we're going to still use J here, equals. Now, if we want to start off on the column right after 3, that's 4. So if we say I plus 1, all the way until our last column, which is the amount of columns we have, which is C. That means if we're on row 3, in this scenario, I plus 1 equals 4. And C here equals 5. And look, if we're on row 3, our diagonal is on column 3, so we want to go 4 through 5. So this works. Then we can say run S equals run S plus, and we're going to index the same exact way. We're going to end this for loop. And then we want to add that answer to our column, or our column vector V. So we say V of, and then I. So if we're on row 1, we're going to add that sum to the first row of column vector V. So say V of I is equal to run S. We're going to end that for loop. So let's trace this so we can make sure that this works. So when we have our function here, we're going to find the dimensions. This finds the dimensions, right? So I'm going to make some notes here. So this is our dimensions. So I'm going to put dim. Then this will pre-allocate. So pre.allocate. So this will pre-allocate. Then this will be our rows. So this, and then this will be our running sum for each row. So this is our sum for rows, right? And since we have this right after we say I equals 1 through R, that means when this loop ends, when we go back, we're going to restart our running sum. That's exactly what we want. We only want the sum of each row, not the whole matrix. So this will go through before our diagonal, right? So we're going to go 1 through I minus 1, because if we're on row 3, I equals 3, and our diagonal is on 3, so we want the element right before that, which is I minus 1. We're going to do a running sum, and we're going to start off after our diagonal, and then we're going to compute our running sum again, and then we're going to basically assign the sum. So we're going to assign the sum to the corresponding row for our output vector V. And then we're going to end that, and then finally we end our function. And that is how you do number 12.